Oh, so he's not going to keep going. I have to take over now. Right. So yeah, as that said, I'm Andy. I work for Reactor. We're a software consultancy in Finland. So yeah, that's enough of that. So I want to talk about feature toggles, what goes bad and what goes wrong, and some good stories. So I can't really see people very well, but who's heard of Night Capital? Anyone? One, two people. Excellent. You already know this story then. So Night Capital were a market-making service. They did financial trading, high-frequency trading on the New York Stock Exchange, I think. And at their peak, they had about $300 million in assets. And remember that number because we're going to come back to it in a while. And they had a slight hiccup one day, which involved feature toggles and a number of other issues which all happened at the same time. So this is their stock price on the day in question. You can see there's quite a drop there. But the drop looks like it was for like one day because it happens on the dateline. This stock price drop happened in 45 minutes. And it's a logarithmic scale, so it's even bigger drop than it looks. So we're going to go through how they managed to achieve that by misusing feature toggles. So they had two features that caused this problem. The first one is called PowerPeg. This was an older feature that they had in their software, and it would take a large buy shares order, and it would take, say that had 100 orders in it. If someone couldn't fulfill all 100, it would take each order and send them one at a time to be fulfilled. And it would count up until it hit the 100, say, and then it would mark the order as completed. This had been in their code base for around 8 years and not used for 8 years behind a feature toggle. At some point, they decided to invent something called SMARS, which I gather is an acronym. I have no idea what it stands for. It does something similar, but rather than splitting orders into individual, it split them into smaller chunks that could be fulfilled. And SMARS would replace the PowerPeg feature. So they reused the feature toggle. So this is some pseudo-ish code of what they had. At some point, they had if the toggle was enabled, and we'd just loop through and submit new orders for each item in the order. Otherwise, we'd just submit the whole order at once. In that submit new order method, we increase the current count of how many orders have been fulfilled. In the preceding 8 years, the code had been optimized to not increment the count on each individual order submission. Instead, it would do it at the end of the first method. So what would happen if that feature toggle was enabled and it can no longer count? So they released their new version, or they wrote their new version, and it replaced that broken feature that wasn't used with this split into smaller orders feature, which was tested. They deployed it to their QA environment. They tested that that worked, and then they deployed it to production. Now, this is where their first little error happened. Their deployment solution deployed it to 7 out of 8 of their servers, but no one noticed that it didn't go to the 8th server. Now, this was a dark deploy, so nothing had gone wrong yet. They then switched on the toggle. So 7 of those servers are now doing the new split feature, which works fine. However, the 8th server is running that old code that can't count anymore, and it's high-frequency trading, so it's now taking an order and trying to fulfill it as fast as it possibly can for forever, because it's never going to hit the total number of orders. So you're essentially trying to fulfill an infinite number of shares, stocks, for forever. Now, someone noticed this about 5 or 10 minutes after releasing, that suddenly they were spending far too much money. So they did the logical thing, if you don't have feature toggles, and they rolled back to the previous version. Now you have 8 servers fulfilling orders as fast as they possibly can, which is worse. Eventually someone noticed and switched off the toggle, and everything went back to the old version, and the problem stopped happening. This whole process took 45 minutes, and they spent $450 million. Now, if we think back to earlier, they only had 300 million odd to start with. That's a large negative in 45 minutes. So yeah, they don't exist anymore. Whoops. So the first rule that comes out of this is don't reuse a toggle. It's not worth doing. If you had used a different toggle, when you switched on your new service, because it happened to only go to 7 out of 8 machines, 7 out of 8 machines would start doing a new thing, but the old service has no idea what the new toggle is, so it would just keep doing the old thing. It wouldn't suddenly start trying to fulfill 1 million orders a second, or however many it is. So don't reuse your toggle. Don't reuse toggles. It's not worth the potential of spending millions more than you possibly have in your budget. The second point is dead code. Why do you have a feature toggle that's around for 8 years and not used? Just delete it. I mean, it's hopefully in source control. I assume they're using source control. So in which case, if they needed it back, they can, get it back from revision history. And if you're doing trunk-based developments or something, or even if you're not, you can just make a commit that removes the feature and just release that on its own. So one little change. If everything breaks, you know it is used. So the rule that comes out of that is really keep your toggle lifespans short. Because if that bad code hadn't existed, well, then when they deployed the new one, and if they'd reused the toggle, but the old toggle code hadn't been in the code base for a long enough time, then they wouldn't have lost all their money and jobs. And the next part is to rename your toggles. Like, 2 of these have got good names. One of them is acceptable. I mean, it is Jira, obviously. But new feature, probably not very descriptive. Because you know what the next feature is going to be called. It's going to be new feature. And now you're going to switch on the wrong one and you're going to lose $450 million, so don't do it. So yeah, name your toggles well, so that they have a purpose. And if they're named properly, you're not going to reuse them by mistake anyway, because enable SMARS is not going to fit as a name for, like, I don't know, spend money. So the next thing I want to cover is the different kinds of toggles. So we've already seen that Night Capital were using some kind of toggle they could switch on and off without having to recompile. So this was probably a periodic toggle or maybe an activity toggle. So a compile time toggle is one where you're using like a compiler directive. So in a previous company we had SQL profiling tools which were quite heavyweight, so we only compiled them in if you had the right flag enabled on the compiler. But that was only ever used when we really wanted to troubleshoot something that needed to be deployed somewhere. Otherwise you'd be in your IDE and you can just use the IDE tools. Startup toggles, like the name implies, are read once on startup and then not checked again through the application's lifetime. If you need to change their value, you just change the value and restart the service. Periodic toggles, check every, and it depends, 5 seconds, 10 seconds, 15 minutes, whatever makes sense for your service in the background. And an activity toggle checks what the state is of a toggle on every HTTP request or every message consumed off a bus. In reality, an activity toggle is probably using the periodic toggle in the background because you don't want that extra latency every time you're handling an HTTP request. Oh, is this feature enabled? I have to round trip the launch darkly, which adds like 200 milliseconds to your response time. Now, while Night Capital used periodic toggles, we're going to look at another company that used a different kind. So who's heard of HP? Oh good, more than one person. In this particular case is HP printers. Their printer division was around the time 400 to 800 developers. Spread globally, they had about 10 million lines of code. They managed 2 firmware releases per year. And of a developer's time, they reckoned 5% was spent on writing new features. 95% was probably fighting Jira. Probably higher than 95%. Maybe not, because we will go into what they were spending their time doing. Because their feedback cycle for when they had a new change that they deployed into or merged maybe into master, the feedback time from committing it was 8 weeks. Now, if you're trying to do test-driven development, an 8-week feedback loop is quite slow. And if you've done something that breaks a build and someone else has taken that branch and built off it and comes to you like 7 weeks later and goes, hey, you broke a thing, Well, I don't remember. I don't want to remember what I did yesterday, let alone 8 weeks ago. So their branching strategy was part of the problem. So what they had, it was a branch per, and I think it was per season, which basically meant a printer model. And then you might have sub-printer models like an 850 as opposed to an 800 would be branched off of that. Now, the red diamonds here are where bug fixes come in. And the little lines represent, commits for things like, enable double-sided printing or add this feature that this particular printer can do. But you want those bug fixes in all of the printers because they might affect more than one. And that's a lot of merges. And if you have to wait 8 weeks to see if your fix has been merged and successfully merged into the right branches, then things are going to go wrong because you might not have done it right, and then someone else has based their branch off your branch, and you might have accidentally brought in some configuration for one of the printers into a different branch, and now suddenly a printer that doesn't have a double-sided end is trying to double-side sheets of paper. And by doing this, their feature toggles were compile time flags. So each branch represented a printer, and it had like an if-define printer DeskJet 850. And then you had if statements throughout the code that just said, if printer is 850 or 950 or 1050 or this model with this particular attachment and this, then do this. And then if you try and port that fix into the other branch, well, suddenly things break. So what they did is switch to trunk-based development, which if anyone knows me knows that I love and will bang on about a lot, but this is not the subject of this talk, so they switched to trunk-based development, and rather than using compile time toggles, switched to using startup toggles. The way this was implemented was that the printer's hardware would tell the software what model number the printer was running. The software at startup would load a configuration file for the relevant printer that had all of the flags in it. This supports double-siding, this doesn't, this has a fax machine attachment, this has color, this one's a laserjet, this one has a half-an-hour warm-up time because it's one of those printers, that's the size of a small office. Which meant that when they were adding a new printer, you were only writing config files. So that can be done in parallel to someone writing a double-siding attachment. When they come to merge in, they can add to all the config files, oh, this one supports double-siding, this one doesn't, this one does, this one doesn't. By also only having one branch, rather than needing their entire cluster of build machines to build every single branch and have 8 weeks running on each branch, they could just have one cluster, or the whole cluster, just dedicated to building master. Their feedback loop for complete testing, which included simulation and emulation, which is different. One of them involves a machine, one of them is circuit boards with like fake printer parts around it, I think. So their whole testing pipeline went from 8 weeks for all of that down to 2 days, which is still kind of slow, but the fact that you're testing like firmware on a physical piece of silicon rather than just running a unit test is a hell of an improvement. And they managed to start releasing their software or their firmware. They could release it, well, basically any time you asked for it. I think they switched to a monthly release cadence, so their builds were always ready, but they didn't necessarily release them. So the point that comes from this is that your architecture really matters. Just because you've got feature toggles doesn't mean you're necessarily using them well. So if you have those if statements scattered throughout the code base, then things are going to get missed when you add or remove them. But if you've only got one place on startup that reads them, well, that's easier to manage. This was also one of the reasons that one of the developers that I used to work with didn't like toggles. He was like, oh, I don't want if statements throughout the code base. Like this. Although it was probably called a new feature. But yeah, he's right. You don't want that scattered throughout your code base because, well, that's going to add your testing load through the roof. It also kind of indicates that you've got your abstractions in the wrong place. If you need to constantly check if a toggle's enabled, then maybe you need to re-architect your code to start with. So in this case, HP got it right. They architected for their toggles. Knight Capital probably didn't. I don't know, they haven't released any source code, and they haven't written heavily about it either because it's slightly embarrassing. Whereas HP wrote a book about this transformation because it was such a good thing, which I've got a link to at the end because it's a good book. So the way you solve this is usually branching by abstraction. So rather than having source control branches for your different printer models, which is insane, you have configuration files, or an interface, or some implementation per printer. Now we're going to use this example a few times because this is going to relate to a story about something that I do with feature toggles. So it's not just me complaining about other companies. Let's say you have an email service. You have a way of sending emails. You have this interface here which dispatches email messages, and then you have two implementations of it. One that uses a web service and one that uses RabbitMQ for transport. Now, on startup of your application, you can configure whatever injection container, or manually if you're not using a container, just to pick the right implementation at startup. Pardon me. Which means that the consuming code actually has no idea that the toggle even exists. It just knows that I've got an interface, and when I call send, an email probably gets sent. And in this case, we have either RabbitMQ or a web service being used. And obviously, when you're writing a test, you'd probably have a fake implementation. This is fine for startup toggles, but you can apply the same kind of theory for toggles that you want to check on, say, every request. So this is just a decorator that picks from one of two options. So whenever an email message is sent, we then check what the toggle is and then send it either via RabbitMQ or via the web service. And you can use a factory or anything else as well. The key is keeping the code in one place. And it doesn't just have to be for the backend code either. This is some React.js-ish code. One of these items, in this list, has a feature toggle around it as to whether it'll be enabled or not. And that's the one-click buy button. One-click buy button is just a normal button, and then at the bottom of it, we're just wrapping it in our is toggle enabled decorator. This is great because if Amazon decides to sue you for using one-click buy because they have a patent on it, you can just switch it off. And no one outside the use of this component needs to care about the toggle. They know that they can import the one-click buy button, and it'll either be there or it won't. And hopefully they won't force it to be on. But by the way, this toggled middleware doesn't exist. It's entirely made up for this. Don't try and find it on NPM, because if someone's put it there, it might work, but your mileage may vary. So with the different kinds of toggles, you have different kinds of usages for them. So with a release toggle, this is where we want to phase roll out some new feature to a business or to our entire user base. A experiment toggle is usually if you want to A/B test something. Let's say you want to check if making your buy it now buttons blink green will increase your click rate than having them, I don't know, flat blue. So you can do small experiments with an experiment toggle. Ops toggles for performance reasons. We have an example of one of these in a minute. And then finally there's permissions. And people seem to love using feature toggles for permissions, and my advice on this is don't. Like, they're similar, but don't. Like, if statements are similar, but you shouldn't use feature toggles for permissions. Because if you do, you'll end up with very long-lived feature toggles, because permissions don't just disappear very quickly. If you do need to use them, you can use this as like a stopgap while you're trying to get some permissioning system set up. And permissioning-wise, identity server or keycloak or basically anything other than feature toggling. So don't do permissions. As we look at this, the more risky your experiment or your operation is, the further on the right of the graph you want to be. So compile time toggle is not very easy to switch on and off, because if you've released a feature using compile time toggle and it's spending money at huge amounts of rates, say $450 million every 45 minutes, a compile time toggle is not great, especially if you're, say, HP and a compile takes 8 weeks. You're going to spend a lot more than $450 million. So if you need something to react quickly, put it on the right-hand side of the graph. In our case, we're going to look at an operations toggle. Now, in a previous company, we had some kind of background indexing process. It put a huge amount of load on the database, and we had one database instance that served as like the real-time transactions and the search and everything. So if you put a lot of load on it, then various websites and CRMs would fall over. So we had a performance monitor attached to the database, and we said if the performance starts getting bad, we will switch on a toggle, which will switch off, or I suppose switch off the toggle, which will stop the background process. The background process was never at fault, but by switching it off, we could switch it off for a couple of hours, let the database recover, and then switch it back on again. Now, we could automate this, and we had the most complicated automation process ever devised. It's a fully learning neural network. I wouldn't quite call him artificial intelligence, because he was the DBA. And if he saw the database was going bad, he flipped the switch. Simple. We wanted to automate it, but it just didn't turn out to be worth doing in the end. We ended up replacing this heavyweight background search process with Elasticsearch, and the problem just kind of disappeared. But it meant that if we wanted to automate it, we could have done, but we'd have had to do more things behind it, because we wouldn't want this toggle to be flapping on and off, because then the background process would never actually complete. And while the background process could be off for a couple of hours before people would notice, if you switch it on and off every 15 minutes, it's never going to actually update all of the data that it should do, and so you're just going to have stale results. So, yeah, we could have automated, but it wasn't quite worth the business investment to do so. So that was operations. Operations toggles affect everyone on the system. And in the case of this, it was a periodic toggle. So every time the machine ran, it checked what the status of that background toggle was. The next one to look at is experiments. Now, as I said earlier, the riskier the experiment, the closer to the right-hand side of the graph you want to be. That's all there really is to say on that, other than it affects generally a small subset of users. You wouldn't deploy this to everyone, but maybe 10% of people, or maybe you'd say, deploy this feature to people over a certain age from a certain town in Australia. And if they're happy, we'll then roll it out to more and more people. Finally, we've got release toggles. Release toggles shift slightly to the left, because they're hopefully not that important, like not risky. You've made a feature, then it kind of works, and now you're going to phase it roll out to everyone. Now, as an example of this, we can come back to that email connector. So at a previous company, we had an in-house CRM. For various reasons, we weren't allowed to send SMTP messages via the Exchange server. We had to do it from another server. So we would take a message, turn it into XML, send it to a SOAP service, which would then deserialize it, rebuild the message, and then send it to the Exchange server to send the message, which was bad for many reasons. The most weird reason was that the Exchange server used to take 800 milliseconds to send an email, which seems slow until you realize that for half an hour every day, it would take 30 seconds to send an email, and we have absolutely no idea why. And also, if you looked at the graph, you could see this half an hour period shifting. So it would shift by maybe 5 minutes every day. So for some days, that half hour would happen during the day, and all of our users would notice it because suddenly their machine would lock up for 30 seconds while it was trying to send an email. But sometimes that 30-second period would happen at night, and no one cared. We got fed up with this because it's terrible and it caused really weird error messages. And if someone had done a mass mailing, and we queued up or we sent each email individually, halfway through their mailing it fails, and now they're like, oh, well, has it sent? Maybe. Some of them have. We don't know which ones, though. Good luck. Send it again. And as our users were quite good at spamming people already, we didn't want to make that worse. The SOAP service itself was also not doing just deserialization and send to Exchange. It was also doing things like add a development mode header if the software was in dev mode, add a different color branding for each users and things like this. So we wanted to do a phase rollout of it. So that's where the email connector came in. We had our new version, which was a worker service, and we had RabbitMQ stuck in front of it. Essentially, the worker would pull messages off the queue as fast as it could to send them, and whenever a user sent a message to RabbitMQ, the second RabbitMQ said that it received it, we'd tell the user that the email had successfully sent. We were lying, obviously, but they didn't really care. And by default, the connector would be using the old version, and we would pick a user to roll it out to. So, if this was our organization, or a very small part of it anyway, we went and found the person who got the most problems. He was an absolute pain to deal with normally because he complained about everything, but that also meant that he cared very much about the software because it wasn't what he wanted. So we asked him if he was keen to beta test new version of Sending. And he was, because, he got a lot of errors with the old Sending, which also implies he was quite a spammer, which he was. So he wanted to use this new thing. So we switched on the toggle for him, and he used it and complained, and we switched off, and we fixed the bugs, and we just went back around in a fairly tight feedback loop with him for a week or so until we'd tweaked all of those little formatting issues and things that crept up as we tried to extract things. Once he was happy, we added his teammate in, who was the second most irritating user who had the most problems. Also his brother. And once the teammate was happy, we rolled it out to his whole team. At this point, we found an issue. The problem is mass mailing. So the first user sends 4,000 emails into the queue because he wants to spam people. The other user sends an email and is on the phone with someone and goes, yeah, I've sent you the contract through. It should arrive in a moment. And Exchange is taking 30 seconds to send an email, and you've got 4,000 items in the queue, and I'm terrible at maths, so that takes a long time. So we fixed that by just having 2 queues, and the worker was told to favor the direct queue and otherwise pull from the bulk queue. And we deployed that to the team, and once they were happy with that, we then deployed it to the next team, and the next, and then to the whole business. The whole process took about 6 to 8 weeks. We were doing other things at the same time. And then we deleted the toggle about 4 weeks afterwards, once we'd made sure that it actually worked. If we look at our toggle usage over time, the percentage of users up on the left and then time along the right, you'll see that the toggle went on and off a lot at the beginning, and then it slowly ramped up to a few more users. We switched it off for a few days while we fixed that queuing issue, and then we ramped up the number of users using it. By monitoring the toggles, we could see how many users were using it and how often it was on for the company. And then once the toggle was being 100% queried and was on 100% of the time for a persistent amount of time, we can delete it because clearly the old code is not used. So that's my next rule. Monitor them, because that way you know when they're not being used. Either they're on all the time, or they're off all the time, or no one's querying it. Just delete it. Because deleting code's fun. So this is another example of looking at it. We have how often the toggle was queried. It's not quite a straight line because we deploy software and not everyone gets it at the same time, and you can see the number of queries rises up to 100%, and then towards the end it just suddenly tails off, and that's us deleting the toggle. So from this you can then add alerts, like has the toggle been queried in a while? If it hasn't been queried in 2 weeks, 3 weeks, whatever your time period is, send a message somewhere. Has the toggle's state not changed? If it's being queried constantly, but everyone's always receiving on, then you've effectively got Boolean as a service, which is, a lot of latency for true or false. The other real key point with the release toggles is user perception. So our first user, who was a pain, he felt amazing because we'd come to him and go, look, do you want to be the first person to have this? And bear in mind, this is an organization of salespeople. If you tell them they can have something that's better than other people's, they want it because they can do their job quicker, they can make more money quicker, they're happy. So he felt great. The next set was his team. They also felt great because they had early access. We're better than everyone else still. And finally, you have the rest of the company, who also feel great because IT released a feature at once, suddenly, and it just worked. They don't know that there was like 6 to 8 weeks behind it of slow ramp up. Suddenly, most of the company received a feature. And of course, there'd been some slight sales happening already because, they're salespeople, and 2 of them had a better system than everyone else. And you can believe that they were telling other people, oh yeah, I'm better. I can send emails much quicker. I don't get those weird bits of HTML error back every now and again. So yeah, user perception is a real key benefit to doing this. There is a downside, and that's complexity. One of the reasons developers don't want to implement feature toggles is the amount of complexity goes up. But at the same time, everything we do adds complexity. We can hide it a bit and we can try and abstract it, but at the end of the day, everything is complexity. You're just trying to keep it as simple as possible, but there's always something a bit complicated going on. So this is happening at the same company, and this is not a good story, and I should have known better because we'd already done the good email rollout. But I didn't, because I'm stupid. By the way, I'm a consultant, hire me. So we had two very, very large projects going on at the same time. Well, technically 3. We had 2 developers, 1 on each project, because that's the optimum way of running projects. And 1 outsourcing team who had read a book about what software development was. That's why there's only 1 commit at the end of their branch. That branch is about a year long, by the way, and didn't compile. So major project 1 in-house, major project 2 in-house, outsourced 1 is just there because it's amusing, really. And at some point, the business decided that it was definitely the internal 1 project that needed to be released. So we rebased it on master, which we'd been doing periodically anyway, and then deployed it to test and then to QA, and then partway through QA, we rebased the internal 2 brancher onto internal 1, onto master. And then the priority changed. Don't release internal 1, release internal 2. You know how difficult it is to undo a rebase that spans a year? And this happened multiple times as well. We learned our lesson fairly quickly. We're like, right, we are not rebasing anything until this is actually in production. If we'd used the feature toggle, we could have had all of these integrated into master repeatedly. And then when they wanted one or the other, it would have just been a toggle to switch on and off, and we'd have saved so much pain. It did take about a week to undo the rebase, which involved backups as well, because we didn't trust what we'd done. So yeah, a release toggle this would have had to been queried in many places about the software. They were really big architectural changes, but they could have been made compatible. But when you're under pressure, you forget things. So yeah, don't split developers on projects, and remember feature toggles can save you some complexity. Another piece of feedback I get a lot is that it makes testing harder. And I can kind of see it. So let's say you've got some feature. You've got a test file for it, unit tests in this case. And you then decide to add a toggle that has a new version of what this code should do. So you copy and paste your test file, like this. And one of them is the toggle state on, one of them is the toggle state off. After you've finished using your toggle, because your experiment's been successful, or you've released your product, or you've decided that your experiment failed and you've deleted it, you just delete the file in question. So for a brief amount of time, sure, you've got more code to test, but we can get rid of it fairly quickly by keeping those 2 tests separate, with toggle and without toggle. Manual testing, basically the same. Take your existing test script, copy, paste. Now go through your test script and just change it for what should happen when the toggle's on. So in summary, never reuse your feature toggles, ever. Keep your lifespan short, if you can. Name them well. Your architecture really does matter, like try and keep them in one place, and monitor them. And if you're only going to do one of them, make it number 1. Don't reuse them. You can avoid the rest of them. But don't reuse your feature toggles, please. And if you do, please tell me how it went wrong, and I will anonymize you for adding it to this talk. And then you'll be famous for bad reasons. So I've got some links here at the end. There's some interesting things about feature toggles from Martin Fowler. Link to this presentation at the bottom. And then the top link is for Knight Capital's investigation of what happened, and the second link is about how HP did their transformation of their business using feature toggles and DevOps, because that's a good buzzword to have. So that's all I had to cover. What questions do you have?